Hey guys, Terry here from LG Electronics. Excited to be here today, and today's mission is to take out 2 old gas furnaces, fossil fuel systems, and replace them with the new LG inverter heat pumps. Let's get started. Back up in the attic on this change out, again, we're replacing 2 gas furnace fossil fuel systems with the new LG inverter heat pumps. And contrary or probably unknown to a bunch of folks is the fact that we're using a traditional styled air handler to replace and use existing ductwork in this retrofit. So as you can see here, we've replaced the existing gas furnace with the new LG vertical air handler, which is multi-position, which means I can use it in 4 different up, down, left, or right configurations. And I'm connecting it to all the existing ductwork that's already in this home. So from a retrofit standpoint, that means I can get in and get the job done. Great news is, by using this system, the power is coming from the outdoor unit, which means I have eliminated the indoor power requirements from a conventional system. All right, so we're getting ready to head outdoors, and I'll let you know that what we're going to do now is we're going to run refrigerant line sets from this point to the outdoor unit, and we're going to run a 14-4 cable or 4-wire connection from here to the outdoor unit. So why don't we go outdoors and see what we're doing next? We moved outside now to the outdoor unit, and working with the contractor, you can see that we are running the refrigerant line sets, which will connect the refrigerant tubing from the outdoor unit to the indoor unit. And we'll also connect the wiring. 4 wires will run from this outdoor unit to the indoor unit to provide the power and communication needed to operate this system. We're getting ready to make these refrigerant connections, and on this particular job site, we're going to use the one of the mechanical fittings out there, push-to-connect fittings, if you will. Quite popular in the plumbing industry. Most of you guys know it. This fitting was specifically made for refrigeration work, so it can handle the pressures associated with the refrigerants that we're going to use today. So you can see here the contractor is about to install the first one. He's going to push and twist until this thing bottoms out. All right, you felt it right there?
Yes, sir.
All right, so that allows that connection to be ready to go. And now the other side of this connection is going to thread onto our flare fitting. You can see that was quite quick. And once we get it properly torqued, which we're going to get the torque wrench out of the truck and set them up. Once we get it properly torqued, this connection will be ready to go, and we won't have to worry about the refrigerant leaks that are associated with handmade flares, or even worse, flares that come on factory line sets that guys are using all around the country. Most contractors around the country are familiar with the flares associated with this technology. On this particular job, this contractor has chosen to use those new push-to-connect fittings, which are refrigerant-rated fittings and designed to be used for heating and air conditioning work. The number one issue with the technology across the country from an installation standpoint tends to be, and always is, an improperly made flare, be it from the factory, as this one was, factory as in this line set manufacturer, or handmade in the field. The flare is a problem, has been a problem, and as a result, drives some contractors away from wanting to use this technology. We have connected the refrigerant tubing from the outdoor unit to indoor unit, and we've also wired the outdoor unit to the indoor unit. So we're entering the startup phase of this deal, which means we need to pressure test the system, we need to evacuate the system, and then lastly, when those are completed, we need to add an additional refrigerant charge. So what you're going to see here are 3 numbers for you. The top number of job site pipe length is 98 feet. I ran 98 feet of copper on this job. I actually had a 100-foot roll and cut 2 foot off for the 98 feet. The unit came charged with enough refrigerant for 24.6, and this refrigerant charge multiplier of 0.43 ounces is printed on the nameplate. So what I'm going to do to calculate the refrigerant charge of 31.5 ounces is subtract the 24.6 from the 98 to give me the 73.4 feet times 0.43 ounces per foot gives me this 31.5 ounces of additional refrigerant charge. That needs to be recorded in this panel, and it needs to stay on the job site so that anybody that runs service on the system in the future is absolutely clear of exactly how much refrigerant is supposed to be in the system. Another thing, while I've got it apart, a pet peeve, folks pay a lot of money for this, and when I show up on job sites, I see this bottom leg of this panel bent because it's been treated poorly, thrown on the ground, whatever. Do yourself a favor, you're professionals, take care of this panel so that when we put it back together, when the job's complete, it looks like a brand new and complete system. We did a leak test. We're right in the end of the evacuation test. We're trying to get it to under 500 microns. That's fancy talk for let's see if we got a proper evacuation on the system. As you can see by our gauge, we're under the 500 microns. So we're about to shut the system down and add back this, or add the additional refrigerant charge. So we'll keep you posted on that. This is another one of our indoor unit choices. This is the ArcCool Mirror, and it's part of a multi-zone system that's going to be installed in this house as well. This particular unit is highly reflective. It lets it capture the space colors, stainless steel, well, whatever colors we're using, but really allows the user to have a separate operating zone so that this room can be managed independently from the rest of the house. The ArcCool Mirror unit that we saw just a moment ago is part of this multi-zone system. The multi-zone system means we're going to connect 2 indoor units in this case to 1 outdoor unit, and that unit that we connected will have a refrigerant tubing and wiring coming from this distribution box, which is fed from an outdoor unit. And then we will replace this indoor unit, just like we did the one earlier today, with an air handler, and we'll have a 2-zone operating system in this home. All right, we made it. We have the system piped, we have the system wired. We effectively passed a leak test, an evacuation test. We've got the proper amount of refrigerant in it. And so we moved inside to start it up, and what you're looking at is the LG Premium wired controller. And literally, we run all our functions from right here, including service diagnostics and stuff. Right now, we have an indoor temperature of 84 degrees. Yes, it's been fun here today. We have a set point of 64 degrees, and we're in the snowflake or the cooling mode of operation. It's this simple. If I want to change the mode, I change the mode and go to heat. I'm not going to do that today. It's 84 degrees in here already. But I would change the mode to heat and then raise or lower the set point to the heating mode or the heating temperature that I want. I got the fan at high speed. I can change the fan to medium. I can change the fan to low, but I prefer high. Across the bottom of the bar in the magenta colored or rose colored icons are different user settings and installer settings and service settings. And so from this LG Premium controller, we can manage all the functions of the system right from this touchscreen display.